Hey everybody, ABC 10 meteorologist Brendan Minchef here with a look at the drought monitor, and we're also going to take a look at the summer that we just had. So kind of review the season and the climate impacts that it had. Of course, it is officially fall at this point, so I think it is appropriate time to kind of rehash the summer. Let's start though with the drought map as of August 17th. This was just before Hurricane Hilary made its way into California. You can see where the drought was. There was hardly any left to begin with, but you can see where the dry conditions were, and it was down in the desert. Well, after we had Hurricane and then Tropical Storm Hilary move through and dumped all that rain, the drought at this point has been pretty much gone. 0.24% of the state right now is in that moderate drought category. Everything else is either abnormally dry or not in any sort of drought at all. Now, technically, the abnormally dry category is not drought. That is either entering or recovering. And kind of in the case of the Klamath River Basin, which is where we see most of that yellow color, that's just kind of some lingering dryness that we had because they didn't see a ton of, they saw above average season's worth of rain up there, but compared to the rest of the state, they did not see as much rain as the rest of California over this winter and spring that we had. Let's talk the precip tracker now. So the month of September, total so far, 0.04 of an inch in downtown Sacramento. That average to date is 0.09, so not very much, but we are a little bit behind where we normally would be. But overall, the water season as a whole, the water year started October 1st, 2022 and runs just a few more days to the end of September. We've seen over 26 inches of rain downtown. The average is just over 19 inches of rain, so we are still 7 inches to the good. Obviously, we'll be finishing this water year quite a bit above average. Now, again, there's only a few days left. In a future video, we will recap the water season, the water year that we had, and the new one starts in just a few days on October 1st. Let's take a look at Futurecast because we have the opportunity to add just a little bit more rain to that total before the year is over. So as we look at Futurecast, most of this rain is going to fall in far northern California right along the coast, but we could have some lingering impacts down in towards the capital region. As we look at Futurecast, you'll see the bulk of the rain arrives early in the morning on Monday for the coast. We could see up to about 1.5 inches to 2 inches of rain. As it pushes inland, it's pretty quickly going to dry out and start to dissipate, but through the afternoon on Monday, we're going to see that rain spreading into places like Shasta and Redding and a little bit further down the coastal range where we could see about 1 inch to 1.5 inches of rain, and then it's really going to start to dissipate. By the time it works its way into the central to southern Sacramento Valley, we're just going to have about a 20 to 40% chance of showers in the capital city, and that's going to be overnight. So more likely than not, even if we do get some rain, you're probably going to be asleep for it, to be honest, because those chances of rain fall between about 11 p.m. and 4 a.m. in the capital city. Anything south of Interstate 80 has much less chance of rain because it's just going to kind of run out of moisture by the time it gets in the valley. But you do see Tuesday by 1 a.m., we just still have those lingering rain chances in and around Sacramento by the time we get late on Tuesday, or I should say late in the morning, around the morning commute. 7, 8, 9 o'clock, rain is pretty much gone at that point, just some clouds. So the Tuesday morning commute could have some wet roads out there, but other than that, your commute for Tuesday morning should be just fine. Again, rainfall totals, not hardly anything in the capital city. If we see anything at all, it's going to be well less than 1/10 of an inch, likely closer to about 0.02 of an inch to about 0.05 of an inch in Sacramento. The bulk of the rain is going to fall right along the coast and along the state line with Oregon as well, and there's good agreement that that's where that rain is going to be. So don't get your hopes up too much for this rainfall, but it does signal that we are coming up on the start of that new water year and of our rainy season as well. September is a month of transition in Northern California and across much of the state as a whole. The average rainfall over the last 30 years downtown Sacramento is just over 1/10 of an inch, and we're not on par to hit that, or on pace to hit that, but we have had a little bit of rain this month. Once we get in towards October, November, December, then our average rainfall really starts to tick up. So we are kind of borderline entering the start of that rainy season. You can see in October, the average rainfall is over 0.8 of an inch of rain. By November, it's over 1.5 inches. And then December, January, February, it's all around 3.5 inches in downtown Sacramento. And we have an El Nino cooking out in the equatorial Pacific, which typically, not always, but typically means a near average or slightly above average rainy season in Northern California. So we have a lot of things working in our favor right now, climatologically speaking, as we get ready to enter our new water year and new water season and our rainy season as well. So lots to kind of get excited about, lots to focus on, but that is not the point of this particular update. That's one for a little later down the road. This one is about the summer that we had, and thankfully we haven't had triple-digit temps for a little while now in Sacramento, but we did have some, and we did have some days that were actually pretty toasty. The warmest days of 2023 in downtown Sacramento were July 1st, 2nd, and 16th, when we made it to 109 degrees. The other warmest days were July 15th, 21st, and 22nd, along with August 16th, when we made it to 108 degrees. Only once did we make it to 107. Only once did we make it to 106. That was August 15th and 17th, respectively. And then rounding out the top five, 105 degrees, we got there June 30th and August 14th. So again, we did have some pretty toasty days in downtown, but not quite as bad as last year. We made it to 116 degrees just a couple days after Labor Day, if you remember that last year. But as we look at kind of climatologically speaking with our triple-digit days in downtown, it's been a very average year. We've had 23 triple-digit days so far. I got to say so far. Of course, there's still time for that to change, but the likelihood of that is very, very low at this point of adding any more 100-degree-plus days to our almanac for the year. So still, technically, so far, we've only had 23 triple-digit days. The average in downtown is 24. So again, very seasonal. Only 1907 had no 100-degree days. And if we think back to just last year, it was a lot hotter. We had 44 100-degree-plus days downtown Stockton. That number was 40. But again, as we looked at just a second ago, doesn't mean it wasn't hot. We did have some heat in Sacramento, and in fact, climate change boosted that heat looking at Sacramento. So this is from Climate Central. This is showing the climate shift index 1, 2, 3, 4, 5. The darker the color, the higher the number, the more influence climate change had on our heat. And thankfully, here in Sacramento, it was a very mild, very average season, and we didn't have that level 4, level 5 climate shift index here in Sacramento. But we did still have some days that were boosted, as you can see by those orange colorings. In fact, most days were boosted by about 2. So that climate shift index of 2. What does that mean? Well, as we look at the legend here, that means strong. There's strong, dominant climate change influence detected on these temperatures, and they were made at least twice as likely than if we did not have a warming climate, did not have that climate change ongoing. So even though we didn't have these high-end categories for the most part this summer, certainly no 4, no 5, we did have a few days in the level 3, but for the most part, we had detectable to dominant climate change influences on our high temperatures this summer. And that was especially the case once we got to July and August. June was actually, for the most part, a below average month. But in general, we are seeing warming in Sacramento during the summertime. Since 1970, really over the last 50 years, we've warmed by 1.7 degrees, which might not sound like all that much. But when you think about it, that's shifting your whole baseline by basically 2 degrees. So your overnight lows and your daytime highs, we're seeing those tick up by about 2 degrees. And so even those really extreme events, like the 109 degrees we saw today, or not today, but this summer, if you think maybe that was boosted by even just a couple degrees, 50 years ago, that would be a 107-degree temperature. So you're shifting that baseline to make these extreme events, these extreme heat days, more common. In San Francisco, that number is 2.3 degrees of warming over the last 50 years. So an even larger influence of warming in San Francisco. And I also want to point out, and go back for a second because I did skip something here. In San Francisco, that warming 2.3 degrees. When you think about it, when you warm up and you have more warm nights, more warm days, you're going to run your AC more, right? Whether you're in the valley, whether you're in the foothills, whether you're along the coast, maybe you don't have AC, but you're going to have increased cooling demand. And that goes for anywhere in the United States, and especially in our hot and humid areas, such as Florida or Texas or along the Gulf Coast, where things do get quite humid as well. And so here we can see that rising U.S. cooling demand, and we're measuring this in quadrillion British thermal units, BTUs. That's the typical measurement of energy and heat and AC and things like that. And so what we're looking at is by 2050, for household cooling demand, expected to rise 71% in just the next roughly 25 years. That's going to rise by 71%. Commercially, that's going to rise by about 30% over the next 25-ish years. And so that is going to have an impact on our climate as well, because that's going to mean we're using more energy to try to cool ourselves off from a rising climate, because of the fact that we're producing these greenhouse gases. So it's kind of this vicious circle where we need more greenhouse gases to produce more energy to keep us cooler because we're pumping more greenhouse gas and it's heating up more. So you can see how it goes in that kind of circle. And as we look at greenhouse gas emissions by sector for the United States, this graph was for the year 2020. You can see transportation was 25% of all of our greenhouse gas emissions in the United States. Cars, trains, buses, any form of commuting, 27%. But the other roughly quarter of that was in electricity at 25%. That is 50%, essentially, a little more than 50% of our greenhouse gas emissions in the United States. And we know that greenhouse gas is what is causing us to warm up, what is causing the globe to be warmer than average. All we have to do is look at a chart with two things on it: carbon dioxide since the Industrial Revolution, and then the second thing is the average global temperature during the same time frame. And as carbon dioxide emissions have risen, we're now over 410 parts per million. This graph ends in 2020, but in fact, we're now over 420 parts per million. Temperature has also exponentially increased. And we know that this is because of human-caused climate change, because of things humans are doing, because of this burning of carbon emissions, of greenhouse gases. Because when we look at a chart over the last 800,000 years, carbon has always fluctuated, and so has climate. And we can see it go up and down over the last 800,000 years. We get these records from tree rings, from ice cores, from sediment under water, such as the Santa Barbara Channel. We do a lot of that because there's not a lot of oxygen in that part of the Pacific, along that part of the coastline. So the record of emissions of fossils, of any gas that was trapped in those rocks, in those fossils, the composition of those fossils, there's very little erosion. They've changed very little, even over hundreds of thousands of years, because there's not a lot of oxygen in that part of the ocean. So that can help us piece together past climate as well. And then we run all these numbers with run all this data with a bunch of complicated math equations, just like how we do weather models, except they're more reliable because we're actually plugging in observed data. And this is how we generate a graph that goes back 800,000 years. But then just over the last 100 years, here we are. So even though it's fluctuated over the last 800,000 years, in just the last 100 years, our carbon dioxide has skyrocketed. And again, that coincides with the Industrial Revolution, when we really started burning those fossil fuels. But it's not all bad news, right? Because we need to also focus on solutions. We can't just say things are bad, things are changing. We also need to talk about how we can help change them back to the better, how we can reduce our emissions. And for the state of California, this is a very helpful chart put together by our friends at Climate Central. One of the ways we can do that is in our transportation sector. Because of our top emitting sectors, transportation is far and away the number one. At 41% of all of our emissions is in that transport sector. And that's obviously just from burning fossil fuels to fuel our cars, to drive our cars, our buses, whatever it may be. We're a big state, honestly, and we have to get places. And the best way to do that a lot of times is by driving somewhere or maybe flying somewhere. And both of those are heavy polluters. So basically, what can we do? We can reduce our demand as much as possible by taking public transportation. We can also use electric and fuel-efficient vehicles, which there are a lot of mandates going out about selling electric vehicles and non-combustion engine vehicles by the 2030s. And then making our cities overall more walkable and bikeable. That's also been a hot topic recently in the state of California. But let's look at another state like Texas, because we're also going to focus on some impacts that we saw in Texas this summer, because they kind of had the opposite summer. We had a very mild summer. They had a very, very hot summer and are continuing to have a hot summer, even though we've now officially entered the fall season. So as we look at the state of Texas, a very similar chart. Their top emitting sector is in industry at 41%, but then you also see electricity at 22%. That's a big one as well for the state of Texas. So most of the industry emissions come from burning of fossil fuels, energy-related methane, and other industrial processes. And of course, Texas is the energy capital of the United States. They drill a lot of oil and gas in Texas, in West Texas, where I used to work. I'm very familiar with it. You can't drive more than about 1 minute without seeing a pump jack or some other piece of oil and gas equipment out there in the fields. It's all over the place. It's a big industry. But one of the things they can do is try to switch to cleaner fuels. They also have the ability to produce more wind power than anywhere else in the country down in Texas. It's just a matter of harvesting and harnessing that renewable energy power. Increase energy efficiency as much as possible and try to come up with some circular material use so that it's not these kind of one and done uses for things, right? So instead of using a one-time product, can we make it so that we can use it multiple times? And the power grid is a big point of contention right now in Texas, because like California, where we kind of have our own grid, they certainly have their own isolated grid, and they run it, and they've had a lot of issues with trying to keep the lights and the AC on down in the state of Texas this year. And I bring all this up. I know we're in California, but I bring all this up because the lessons that we can learn from Texas this summer, we can shift out here to California as well. Even though we had a mild year, we kind of had a year off of having to worry about the power grid, of having to worry about the extreme heat and some of the impacts from climate change, but they are still happening. And one of these days, maybe it'll be next year, maybe it'll be the year after that, things are going to flip back again. We're going to have that extreme heat, that extreme weather whiplash, which we actually had a lot of this winter when we had really dry conditions for the last 3 years, and then suddenly we had a very wet winter. It's all part of a changing climate, and I spoke with a meteorologist from Climate Central about this very topic. Take a look.
Well, it wasn't as hot as it's been in recent years.
Caitlin Trudeau, a senior research associate with Climate Central, agrees with the assessment that this summer was, all things considered, pretty seasonable.
And we were having a lot cooler temperatures, especially in June. But then eventually over July and August, we started to reach back up to higher temperatures. But overall, it was just about 0.29 degrees Fahrenheit above the 1991-2020 normal. So not extremely hot, but definitely cooler than some of the last recent years. But we did have some hot days. And that's kind of what we're seeing, is not necessarily that every day is really hot, but that the extremes are getting warmer and hotter, and that those are happening more frequently.
In Sacramento, summer is 1.7 degrees warmer, on average, than 50 years ago. And that shifting baseline is making extreme heat days more common, even in years like this one, that are overall fairly average.
You know, not every single year is hot, not every single day is hot. One thing that we do know is when we look at the summer's maximum temperature, the hottest day of the summer, we're seeing that temperature is actually much more unusual. So summer's hottest day is getting hotter, and those are really unusual temperatures. Last year we saw 116, extremely unusual.
And just to be clear, just because we had a mild summer in California this year doesn't mean climate change isn't happening.
So that's really that interannual variability that we see everywhere.
While California benefited from that interannual variability this year, other places were not so lucky.
Texas, Louisiana, we've seen some really horrible heat, and it's not just that it's getting super hot, it's that it's staying hot for a really long time. So we saw a lot of places in the South that broke their records for consecutive days above 100, consecutive days above 105, consecutive days above 110. I mean, we're seeing this massive amount of time where temperatures are not dropping below the triple digits, and that's really concerning for a lot of reasons, but especially for human health. Well, because there is a limit to how much heat our bodies can take. And out west, we don't have that much humidity, so that kind of helps. We can withstand higher temperatures as long as it's not too humid. But what happens when you get more humidity as well as higher temperatures, it really increases the physiological stress on your body. And that heat stress is going to reach a point where if it gets too hot, your body stops cooling itself down. So we lose the ability to cool ourselves down by sweating. And so when that happens, you start having organ failure, and that is just incredibly dangerous. That was the thing we thought would probably not happen until, way off in the climate change decades ahead. Earth just had its hottest northern hemisphere summer, record-shattering, really dangerous. And nearly half the world's population experienced temperatures that were made at least 3 times more likely due to human-caused climate change. We're talking like 1.5 to 4.2 billion people experiencing this kind of heat every day throughout the summer. So it's very widespread, and climate change is really boosting the heat. It's really boosting that kind of stress that we're feeling all over the world, and it's manifesting in different ways. Not only are our oceans like hot tub temperatures, but we're also seeing major floods. We're seeing major wildfires. I mean, it goes on and on. We're seeing streaks of 110. you really look around and it doesn't take a long time to really see that climate change is everywhere around us.
But climate change is more than increasing temperatures and warmer oceans. It's more than melting sea ice and rising sea levels. Yes, all of those things are happening, but it's also about the impacts from those events. For example, hotter, more humid days mean more people using air conditioning and for more hours. At times in Texas this summer, ERCOT, the Electric Reliability Council of Texas, akin to Cal ISO, has struggled to keep the lights and AC on. In August alone, ERCOT issued 8 conservation appeals, and on the evening of September 6th, ERCOT came within 500 megawatts of rolling blackouts in an effort to prevent the Texas power grid from failing. This is not something we are unfamiliar with in California. Think back to last September. Remember the texts and phone calls we got during the 116-degree heat wave in a last-ditch effort to save the California grid?
It's really interesting to take a look around California, take a look around the United States, and just see that we really don't have what we need to continue to survive in this kind of climate, this kind of environment. It's really troubling. So when you think about it, our power grids are not built for the climate of today, and they sure aren't built for the climate of tomorrow. They're really built for a world that doesn't really exist anymore. And so that's really concerning because we don't have the infrastructure to support society's needs when it gets really hot. So we see these shut-offs in powers. We see it here in California when you have the public safety power shutoffs, when we have fire weather. But you also see it when there's high demand in these hot summer months. You see these alerts come out and saying, please conserve energy. The power grid is having a hard time. So it's not something you can escape, and it's something that's going to continue to be a problem as temperatures continue to rise. It's a much different world now. And you see even with, what was Hurricane Hillary, I mean, Los Angeles and Bakersfield had their wettest summer on record basically coming in one day. And when you think about those tropical storms hitting Southern California, it may not, sound like a huge deal, but the infrastructure, our homes, our communities, they're not built to withstand that kind of power that comes with these storms.
Does one tropical storm mean that California is becoming more prone to hurricanes? Not necessarily. More work needs to be done to assess how climate change may affect our tropical risk. But one thing that we are sure of is that climate change is here, and it's happening now. This past summer is perfect proof of that.
It's really hard to sugarcoat it or to try to step lightly. The science is there. Scientists are not in disagreement. I mean, but there's been a huge campaign of doubt that has been it's been very well planned and played out. And so I think that unfortunately a lot of people are just confused, and they've heard some facts that maybe aren't right, maybe aren't accurate. But when it comes down to the science, we know what it is, we know how to solve it, and we're in agreement. There used to be like a stat like, only like 50% of climate scientists believe it. It's just not the truth. Scientists are in agreement. It's happening. It's now. it's serious, but it's solvable. It is, and I think that that's kind of a harder point to focus on sometimes, because it's all doom and gloom and a lot of horribly scary things that are happening now and will continue to happen. But I think it's important for people to remember that we can do something about it, and to not lose your agency and your ability to care, because there are choices we can make, and there are options that we can stop the worst impacts.